Okay, so this is the problem. So I have a fidget spinner, you know those things, right? Spin. And I flick it so it's going with a starting speed of 150 radians per second. There's a little bit of friction that gives it a constant angular acceleration of negative 1.35 radians per second squared. So the question is, how many times did it rotate? How many times did it rotate? So really, we could say theta 1 is 0, theta 2 equals we don't know. But we do know another thing. Omega 2 equals, what's the final angular speed? Well, if it starts here, and we want to find out how far it goes, it's going to stop. So this one's 0. Okay, so what do we do? There is a kinematic equation that you could use, but let's just start from basic ideas. So let's say I know omega average is delta theta over delta t. But I don't know time. I don't know delta theta. But I know another expression for the angular velocity, the average angular velocity. It's going to be omega 1 plus omega 2 over 2. Those things are true. Okay, so I actually know the average angular velocity. I know that because I know the starting, I know the final, and I know 2. So this is 0. So I get omega 1 over 2 is delta theta over delta t. Delta theta is omega 1 over 2 times delta t. Just multiply both sides by that. But I don't have the time. So what do? I quit? No, don't quit. That's not the right answer. Okay, so the answer is, let's look at the definition of the angular acceleration. Alpha is delta omega over delta t. So there's another expression for delta t. So I can solve this for delta t and put it up there. Okay, so we know the change in angular velocity is going to be the final omega 2 minus initial omega 1. So I can solve this for delta, that is 0. So I can solve this for delta t. Delta t equals negative omega 1 over alpha. Okay, radians, that's right. Radians, that's right. Okay, just checking the units. It's early. Okay. So now I can put this up here, and I get negative omega 1 squared over 2 delta, then I have alpha on the bottom. Yeah, that's right. That's squared. Yeah, because I have an omega times omega, negative omega 1 is negative omega 1 squared. The 2 is down there, and then the alpha's on the bottom. And this is radians per second squared divided by, that's radians squared per second squared divided by radians per second squared is going to give me radians. Good. Okay, so that's it. We did it. And we just need to put it in our stuff. So let's say my negative 150 squared over 2 times negative 1.35. And the negatives cancel, so I get a positive angle there. And that's going to be equal to, let me put that in my calculator. I should have had this prepared, but I didn't. 150. I get 8,333 radians. Now, I said how many times does it rotate? I didn't say the angle. So we need to find the rotations. The number of rotations this is. Well, one rotation is 2 pi radians. So theta equals 8,333 radians times 1 rotation divided by 2 pi radians. So if I divide that by 2 pi, I should get it. I get 1326. That's a lot. There you go. If you wanted to find something else, you know what you could do? You could solve for that time. You could say, how long does it spin? I'm not going to do that. You can do that if you want. But I answered the question, how many times did it rotate? Now, if you think about this problem, it's just like one-dimensional kinematics. Instead of angular velocity, you have velocity. Or instead of velocity, you have angular velocity. Instead of change in theta, you have change in x. Instead of alpha, you have acceleration. But then the equations are all the same. So it should be a little familiar to you. But there you go. Rotational kinematics.